afternoon, and good evening to everyone present over here. Hope you all are doing well and staying safe. Greetings from the team Petroleum Engineers Association. I am Niharika from Team PEA. Welcome to this 2 days free workshop on surface production operations by Dr. Hussein H. Ahmed with 38 years plus experience in oil and gas industry. Thank you for joining with us in this workshop. Now, without wasting any further time, I would like Dr. Hussein H. Ahmed, sir, to start this educational workshop. Thank you. Over to you, sir.
Thank you very much, Niharika, for the brief presentation. Yes, within these 2 days, today and tomorrow, we will talk about surface production operations. And also, we mentioned the facilities used in the surface for these operations. After getting the oil out of the wellhead, what shall we do with it? How can we make the oil suitable for the market, the crude oil? So that's the aim of this workshop today and tomorrow. And during that, we will cover a few activities and a few points in that agenda. As Naharka mentioned, I am a petroleum engineer. So I am in the heart of the business. And I have more than actually 40 years of experience mixed between academia and also industry. I used to work in the oil fields, onshore and offshore. I worked in Iraq onshore, south of Iraq, in Rumaila, Basra, and also in UAE, Abu Dhabi, Adnoc. And I work in Aberdeen in Scotland, North Sea. So I mix between onshore and offshore. My PhD in reservoir engineering, but my MSc in production engineering. So I mix between production and reservoir. Today will be about production and try to share with you my knowledge, my experience, my humble knowledge and my humble experience. And I'm sure somebody may be in the audience much better than me. I'm just learning, but I will share with you my learning. I do encourage especially young generation also to widen their knowledge and to widen their skills. You have to mix between knowledge and skill. Qualification is not enough. Qualifications is a piece of paper, but the skills is part of your operating life. So enhance your skills to support your qualifications. Currently, I am based in UK in England, and also I am a director now for academia based in Liverpool. I'm international training and education director in Liverpool Academy. So I will share with you my knowledge, my experience as well. I am retired, but I'm doing these jobs here and there to keep me alive, to keep me busy, as well as to share my knowledge with people, with young generation. It's very important. If you have knowledge or experience, don't keep it for yourself. Share it with others. Share it with others. And that's the aim of this free webinar. And I would like to thank Mr. Nikhil from Petroleum Engineering Association for this opportunity. He approached me, he asked me to give this workshop, and I said yes, as long as we are serving the people. So that's the start, and thank you for the audience to be with us today. My agenda for today, we talk about general introduction for oil and gas industry. I talk about surface facilities, about the oil and gas separators. What shall we do with the produced water if it's come to us as a surface problem, the emulsion? what are the treatments needed for the crude oil during the production of oil? Why do we do it and how do we do it? And I will mention a few problems, technical or operational problems, and I give you solutions as well, production problems. Maybe on day number 2, I will talk about also health and safety and environment, little bit, connecting the production with health and safety, and always question and answer is open for you. If you want to ask, feel asking me or write your questions in the chat box. I'm assuming that our friend Nikhil is recording now, and that record will be useful later on. I think Nikhil mentioned to me that he might, maybe, depending on his timing, he's a busy man, he will issue also certificate for you, which could be useful and good. So thank you very much. This is me, and this is the agenda for today and tomorrow. Today we'll spend about 90 minutes, almost 2 hours maximum. I wish I can talk more, but because I'm in Ramadan and I'm fasting, so if I keep talking too much, I will be feeling thirsty, which is a bit challenge. I cannot drink water. Okay, surface production operations. The title of our workshop is slide in front of you. It shows to you I can say the integral activities, starting from the upstream, which is the piece of rock under the ground, very deep sometime, which we name it in metrology during the formation. Some people call the pay zone or the oil formation. That could be limestone, or could be sandstone, or could be shale as well, having oil and gas inside it. Once you reach it and punch it and drill it and make something in it, the oil and the gas will come to the surface through the producing well and passing the Christmas tree and the wellhead. I will talk about the wellhead tomorrow. The wellhead and the assembly of the Christmas tree, I will mention that tomorrow to you. So then the oil would go through the flow line. First, it comes to the separator, oil and gas separator. Of course, the oil and come from the well or wells. Sometimes you connect 5 or 6 wells together in a, what they call them, gathering station. And then you send them to the separators. And from the name, the separation process takes place in the separator, taking the gas out from the oil. Even sometimes the people call degassing station, degassing station. Remove the gas from oil. That gas will go to the surface as well, and we do some activities with it. Tomorrow I will talk about the gas. Today mainly I talk about the oil. And then that oil will be treated in a processes. We call them oil treatment operations or processes. Could be dehydrating, they call them dehydration. This was dehydration. This is an operation. Dehydration is the process into which I remove the water from oil. I take the water out of the oil to make the oil suitable for the market. That oil will be stored and pumped and stored in a tanks, the tank farms. Today I will talk about tanks. Today I will talk about separators and our tanks as the surface facilities. Tomorrow I will talk about the wellhead and the gas treatment. And by this, we cover the production operations or some of it. Not easy to cover a big topics in only 2 hours and 2 hours, 4 hours maximum, but we try our best. Then within that process of increasing production, people may use something else. They call them artificial lift, gas injection, or gas lift sometime. Sometimes they use also water injection, gas injection. These other things we could be mentioned later on. But today, we mainly talk about surface production operations. Today, I will talk about the gas separator and the oil treatment. I will talk about the tanks. Tomorrow, I will talk about the gas processes and treatment. And also, I will go back to the wellhead and talk a little bit about the wellhead assembly. I hope I encourage you, if you have a piece of paper and pencil, try to take some notes, because some kind of information I will give you today, you cannot find it in books. I know them because I have seen them. So some knowledge I give you has come from my experience, not from reading books. And I hope that will be useful. Tomorrow also, I will talk about water disposable, the emulsion as well. According to the agenda, I will do my best. And also tomorrow, I will hit a little bit, talk maybe 10 minutes or 20 minutes only about the health and safety. Again, you can write your questions on the chat, and hopefully that will be useful and will be answered later on. You can write the questions in Arabic or in English. I don't mind, because I speak these two languages, Arabic and English. So the oil now leaving the wellhead, flowing through the flow line, crossing the choke valve, from the choke valve flow line to gathering station, collecting station. Every 5 to 6 wells gather together, and we send the production into a separator. So what does separator do? How does the separator work? What are the components inside the separator to help me separating oil from gas? This gas, which came out of the separator, sometimes I called GOR, gas oil ratio, or some people call it associated gas, which is need to be treated to be suitable for the market. The oil also need to be treated to be suitable for the market. The market cannot buy any crude oil unless it meets certain standards, which we're going to mention today. So in basic principle, the oil is leaving the well, go to the separator, and due to a pressure differences, always remember, the pressure in the separator is less than the pressure in the wellhead, maybe by 100 psi less, could be 200 psi less, depending on. And that reduction in the pressure will make the gas liberated, come out of the oil. And sometimes, if only one separator is not enough, you put stages called separator trains. Stage 1, stage 2, stage 3 maybe, in order to separate all the gases out from the oil, stage by stage. A pressure drop by pressure drop. Until at the end, you keep the oil inside the tank, storage tank. They call the dead oil, D-E-A-D, dead oil. Why dead oil? Because it has no gas in it at all. It should be zero gas dissolved inside it. That's one of the conditions. To buy an oil from the market, it should be free from gas. So you do it stage by stage. Even on the tank, there's also sometimes we have breathing valves. or they call VRU, Vapor Recovery Unit. I will talk about tanks later on. So that is the surface operation. One of the most important surface operation is the separation process, the gassing process. Separators could be of different shape, different size, different design, both externally and internally, but one principle. The principle is to separate gas from oil and also to separate water from oil. So in the separator, I have one input, but I may get three outputs: gas, oil, and water. It depending on the properties of my crude oil. So that is, for example, the wellhead. This is just a typical flowing well, I can say. Natural flowing well, natural sometimes, and sometimes, of course, the well could be flow and produced artificially. So this was the production equipment, which is our workshop is about the production equipment and operations. It goes, the first equipment would go to it is the separators. I need to know how it works, what's inside them. At the same time, I need to know this oil flowing in the flow line from this well, is it natural flow? Depend just only on the pressure of the reservoir? Or did I use something else to make it producing, such as a gas lift or ESB or the RSP, the rod sucker pump? Did I do any water injection or water flooding? Did I do any gas injection or gas flooding? These are important. Why important? Because it will affect on the production rate and also on the content of the crude oil. If I do water flooding, I should expect the water ratio is high and the oil come to the separator. We call it water cut, a water percentage. Same thing, if I do gas injection or gas flooding, I should also expect the gas coming with the oil will be larger, more quantity. So this is also important to keep in mind, will affect on your surface operations. Most of the people in mature fields or fields, they are suffering from water cut. They say we are very much suffering from too much water coming to our separator. And this problem sometimes because of emulsion, because of scale build up, because of corrosion. And then I need to know the water coming from where. Is it natural water or because of my water injection or water flooding or whatever? So it's important to know what do you use, what have you used in order to produce the oil from the wellbore. So that is in general, this slide in front of you now is about surface production treatments. I can name some. So production come from the well or from wells. 6, 7, 5, 2, whatever numbers of wells, you connect them to a separator. And that separator will do treatment later on. The treatment will separate the oil into a water which need de-oiling. This is an operation. And even the water, after you remove the oil out of it, what shall I do with it? Shall I throw it in the open lake or open river? The answer is no, because still has something inside it. So I need to have a disposable well, for example, to inject that water in a certain formation in the ground. Or maybe if I treat and keep it treated in a proper way, I may use it later on for water injection. If somebody asks me in a production, I have produced water, but I have treated that water. Now the water is treated very well, has a good pH value, it has no any sand particles, not much oil left behind it. Can I reuse it in water injection? The answer is yes, you can. I'm talking about the water after de-oiling. The oil also need to be treated well, but remove more gases out of it, degassing, take all the gas out of it, if you can, as much as you can as well. And then take all the water out of it, we call dehydration. After that, if it's clean and nice, suitable to the market, you sell it. The gas, leaving the separator as well, need to be treated very well. A process called sweetening, and a dew point conditioning, that means dehydration. A dew point conditioning means dehydration, removing the moisture content, remove the water vapor from the gas. And then after that, or before actually, and then you remove H2S and CO2. Usually we remove CO2 and H2S before dehydration. This box, the box in the middle, they name it sweetening process, sweetening. And the box on the top, they call it dehydration process, dehydration, using glycol. And of course, after that, the gas could be gone through into compression to pump it in a pipeline to the customers, or sometimes compression and cooling to change it into liquid gas, LPG, for example, or LNG, liquid natural gas, which I will cover some of them tomorrow. So remember, this slide in front of you, summarizing the whole story of production operations after the wellhead. Slide in front of you, it tells you what do we do with the crude oil. Remove water and treat the water. Remove the gas and treat the gas. Take the oil and also treat the oil to make it suitable for the market. People talk about oil price, $65 per barrel. They don't pay it for any oil. No, they paid only for the treated oil, a very well treated oil. If the oil is not treated very well, you will not get $65. Nobody will maybe buy it from you. Remember these, and this is the importance. Yeah, and somebody asks you, what's the importance of these operations? The answer, I want to make the crude oil meet the market standard, so I can sell it to the customers in a good price. I mentioned to you the principle of separations is based on the idea of gravity as well as on the idea of pressure differences. So pressure differences and gravity will be separating, segregating oil from water, because water is heavier than oil, and gas come out due to pressure differences, and then you will do that. This, I will let you know now. I will not go through the slides one by one or word by word, no, because there's no time to cover that. And so I will give you a nice brief ideas. Of course, does the separator take all the gas out from stage number one? The answer is no. Some of the gas could remain. If plenty gas remaining, then I have to build a stage number two or stage number three. They call the trainers. And does the separators only take the gas? The answer, no. It takes the water out of it. So what do you mean? I mean, in this case, I have a barrel or a vessel or a tank, which has three compartments inside it, one for gas, in the middle oil, underneath we have water. Sometimes we call it three-phase separators. So separators need to think about pressure in it, capacity of it, flow rate, how much in, how much out, retention time. How long does the oil stay in the separator to be separated? How many? 1 hour? 2 minutes? The answer is no. No more than 3 minutes. Sometimes even less than that. 2 minutes, 1 minute is enough. You cannot leave the oil inside the separator for a long time. It's a continuous process, continuing every single minute. So the retention time is short time, should be 3 minutes. They say between 30 seconds and between half a minute to maximum 3 minutes, depending on how much gas in it, how much water in it. As well as the other things in the oil. Does the oil have sand? Does it have paraffin, wax, in other words? Need more chemical additions or additives? It does have salty water, and the salty water has a scale. The scale is made of calcium and magnesium. So if that water coming with the oil rich with calcium and magnesium, and then they're building a scale inside it, these also important to be looked into in terms of a treatment or operations of the produced oil. Remember, our workshop is about production operations. So these also need to be looked into. If you don't, sometimes you have too much paraffin in your crude oil in cold weather, winter time, some of the pipeline could be blocked by the wax buildup inside the pipeline. The foam problem as well. Crude oil mixed with gas making you foamy things. So I have to add chemical called the anti-foam additives in order to remove the foam from the crude. Otherwise, the separation will not be successful. For foaming and defoaming, defoamer, they call it anti-foam additives or defoamers. It could be mechanical inside design by having some kind of baffles inside the separator to break the foams, or add chemicals to break the surface tension between the gas and the oil and remove the foam from it. The problems, corrosion. Do I have H2S in my crude oil, or do I have mercaptan, sulfur compounds? They call them in chemistry thiosulfate. Thiosulfate, a radical connected to a sulfur. These are corrosive liquid. We have two types of corrosive things inside, or three types of corrosive things inside the crude oil. The H2S as a gas, thiosulfate as a liquid, and salty water. Salty water, because salty water is also a corrosive environment. So I need to add what they call the corrosion inhibitors as well inside the separator, later on in the tank, later on in the pipeline, to stop that. So foam, corrosion, impurities, sand and paraffins need also to be treated and to be taken out. Of course, sand need to be, you have to wash the separator from time to time to remove the sand, which could be gathered at the bottom section of the separator. Retention time, I mentioned that to you. It should be between 3 minutes to 30 seconds, between half a minute to 1 minute to 3 minutes, no more than that. Should be sufficient to separate oil from gas on the size, depending on the size and on the flow rate. Don't forget as well, retention time also sometimes depending on the API of the crude oil. A lighter API, higher APIs, need more retention time. But if you have heavy oil, maybe smaller because there's not much gas inside it. Heavy oil with API 24, 22, 20, usually they don't have too much gas inside them. They don't have too much dissolved gas inside them. They have asphaltene, yes. They have paraffin, yes. They have sand, yes. But not much gas inside them. Lighter oil, API 33, 35, 36, 40, they have a higher GOR or higher gas inside them. So the retention time should be not very big, should be continuous, not very large, not very long, and it should be in short time to be done in this case. You have the re-entrainment, which is a problem of like splash between gas and liquid or gas and oil. And these are like misty things. And these could lead to what I call carryover, liquid carryover. So it should be to the minimum, and we have to minimize the re-entrainments or the splash or the misty things by at least controlling the pressure and make the pressure always steady in this case. Separator could be done on one stage or two stages, depending on how much you want to remove the gas, as well as we have something called the free water knockout. Especially if you have water cut is very high, then it's recommended to put the oil into a big tank, leave it quiet, leave the gravity work, and by this the water will be taken first and the oil will be on the top of it. We call the free water knockout. This example again about, or this slide in front of you, about one common problem in the oil, on the produced oil, and the emulsion. This word, remember this word, emulsion. Emulsion is a problem. If we have too much emulsion leaving the separator from the free water knocked out or from the separator itself, then it's not good. And always also remember, take it a note from me, the higher the water cut, the more the chance for emulsion, the more the chance for emulsion. Emulsion is a mixing of two different liquids, water and oil. They don't mix in a proper way because of difference in viscosity and difference in surface tension, but they create a phase which is maybe the main body is water and oil inside it, and we call it an oily water. The main body is water and oil inside it, an oily water. Or the opposite, the main body is oil, and we have some droplets of water suspended in that body of oil. They don't settle down because either the oil has a big viscosity, or maybe the oil is heavy oil with a big gravity factor, or the size of the water droplet is too tiny, too small to settle down. So we have an oily water and we have a watery oil. Major body is oil and some water droplets aside need to be treated. We're going to, inshallah, hopefully today I will explain some of them. These are in gas reservoir, so I don't talk about it now. The separators will be different types, could be vertical, could be horizontal, could be spherical, could be two-phase, three-phase, and so on. And the separator is very much based on the idea of we have different pressures built up, and that will help in dealing with them. As I said, I mentioned to you that the separator works in the principle of pressure differences. The pressure inside the separator less than the pressure from the wellhead. That will help to the gas to come out. And also gravity factor. The water is heavier than oil, so it settles down because of gravity. We have something called sometime at the bottom of the well called Vortex Breaker, a small mechanical unit at the bottom of the well, at the bottom of the separator, on the outlet of the water and the oil pipelines, or takeoff. These are preventing the escape of gas with the oil or the water, break the vortex. So I will, okay, this is, for example, we have here a vertical two-phase separator. This is example of it on site or location. This is the diagram of it. Okay, that's what I want. I want this slide. So this is a basic one. A basic one used in certain oil fields. We call it vertical two-phase separator. Based on the idea of pressure differences, I get the red. Now the gas will go up. And based on the principle of gravity, I get the green part, which is oil, and water come down. Two-phase, because it separates liquid from gas. This liquid could be pure oil, could be pure water, could be oil and water. So you have a flow coming from the wellhead or from wells, more than one, coming inside the separator at a certain pressure. Could be the pressure 200 psi, 250 psi sometimes 300 psi. And the size of the pipe goes inside about 6-inch, sometimes 8-inch size of the pipeline entering the separator. Once enters, it hit a baffle and they separate gas from oil. That gas need to be treated later on, and the oil also need to be treated later on, as we mentioned earlier. We have something called the level indicator. Sometimes you have here a sight glass as well to see the level of oil in the separator. But this is, of course, a controller. A signal will go to this valve, a control valve. So if the level of the oil is building up and too much oil, it will open wider and take it out. If the oil level is getting down and down and down, and the water is coming at the bottom, then a signal will go to the valve to be closed, to shut, not allow the water to come, separating. So the oil level drops, close, or open the valves according to the oil level. You set it up at a certain level. This another type of separator, we call them, again, I repeat myself, separator, vertical, horizontal, spherical, two-phase, three-phase, all work under one principle. The principle is to separate oil from gas, or gas from oil, based on a pressure, a drop, a pressure, a dropping, and separating water from oil based on a principle of gravity, density differences. Whatever it is, the shape of it doesn't matter. This is a horizontal two-phase separator. This is very much common into gas condensate reservoir. You see the blue part is gas, much larger than the red part, which is the condensate. These are very much used in gas fields or gas condensate fields. This in the middle, the baffle in the middle, sometimes we call them demister, DE, mister, or mist extractor. So if the gas passes through and it has some droplets of liquid, the droplets will be cut here. And they fall down and you take them from the bottom. And the gas leave the separator almost, I not say 100%, but almost free from the liquid, free from the condensate. In the entrance of the separator, this one, we have something called the inlet converter, or sometimes inlet baffle, or he called momentum absorber. Also, these are to slow down the movement and to also help separating the liquid from the gas. I repeat, we have vertical two-phase, we have horizontal two-phase, same principles. Another example of horizontal two-phase as well. These are for oil, this is for gas condensate. Oil production go through the inlet, Because of this baffle, it will help the first stage of separation. They call it inlet diverter. Sometimes we call it inlet cone, C-O-N-E. Some people call it inlet baffle. Different names actually. This will help in first separation because it reduces the momentum. Momentum in physics is equal to mass multiplied by velocity. So we reduce the velocity. That will help in separation. The heavy part, the liquid, come down and the gas will go up. And before the gas leave to the out, it passes through something called mist extractor or demister. Same this one called here mist extractor. This horizontal vertical one. Here also small part, like a mesh. That will help in capturing the droplets of liquid. Could be down to 1 micron or 5 microns sometimes, depending on the way. This has problems. I mentioned problems. One of the problems in demister sometimes it could be blocked. A block. Why block? Because this gas may be having some sand particle, maybe has a wax in it, asphaltene. So after 2, 3, 4, 6 months, this demister is totally blind now. Blind. The gas cannot leave out. So the operation is stopped. I need to wash it, clean it. Sometimes we can inject some solvent to clean it. Sometimes you need to shut down and you wash it from inside, and therefore it's a problem. If the demister is blocked and no gas come out, what could happen inside the separator? The answer, the pressure builds up in the separator. And building up pressure in the separator, sometimes the gas could be dissolved inside the oil and the liquid. And it goes with the liquid out because not separated. And that's a problem. How do I know the demister is blocked? I can monitor the flow rate of the gas. I have flow meter. Or I can monitor the pressure gauge on the separator. If the pressure is building up or little gas is passing through, that means we have problem with the demister. Could be blocked. And the opposite. This demister with time, if we have plenty H2S in this gas, the H2S will start corroding the demister. Corroding it, it make a hole inside it. It will not work very well. Some liquid will carry over, called liquid carryover. You find the gas has too much liquid inside it. That means the demister is not working well. It's allowing the liquid to pass through. The liquid also could be passed through due to the level of the liquid coming up, because we have problem in the liquid out, in the oil out. The valve could be semi-closed or half closed, or have too much flow rate inside, more than the capacity. So that level is growing up and then some of the liquid come out. Or I have kind of splash, I have fluctuation. I have what called intermittence, or we have mist, M-I-S-T, too much liquid vapor hanging in the gas itself. So that liquid will pass through the demister and go with the gas, and we call it liquid carryover. These are issues need to be looked into, are some of the problems. We have a problem also called gas blowdown. If the demister is blocked and the pressure is built up, some of the gas will force itself through the body of the liquid and come out. Or if the liquid level getting small, and then some of the gas will escape. This issue of gas escaping from the bottom of the separator, we mentioned earlier, we can stop it by having something called Vortex Breaker. Vortex Breaker. So these are some of the problems. inside the separator. Pressure fluctuation, splash, carry over, gas blow down or blow by, they call sometime, demister blocked or demister broken, corrosion issue due to H2S. Sometimes we have too much water, then scale build up, and so on. We're going to see some of the slide clearer later on. You see the designing here. I just want you to compare between this simple design here. There's another way of designing, but same principle. These red arrows is the path of gas passing through this mist or demister. Here we have the inlet is vertically with the inlet diverters. Here we have the inlet diverters a bit horizontally. So different design, but the principle is same principle. I mentioned the gas could escape with oil. They stop that by having something called Vortex Breaker. If somebody asks you what's the purpose of Vortex Breaker, the answer, to stop the gas escape with oil. To stop that kind of swirl take place inside the body of the separator. This is horizontal two-phase. This is horizontal two-phase. This is horizontal two-phase. This is vertical two-phase. The most common one, usually, this is also horizontal, vertical two-phase, same principle I mentioned earlier. Same idea, so I'll not go through it. Of course, there's some other factors need to look into. If you are a designing engineer, then the question, how do they design it? How do you know that they know this size of separator is enough for this oil field, or this is gas oil ratio? So we have designing elements, calculation elements, in terms of they call the gas space or the gas apartment, the top one. And they calculate that according to the pressure, density differences, diameter, discharge coefficient, and so on. So this is not our topic for today, but it could be in more details if we do a course on that. Then we have more time to explain and to do calculations. Again, the gas volume, VG. How do I calculate? We have some equations to help us to know the gas volume, the gas apartment, this part. How much is it? How can I calculate the size of it? This is the equations used for that. Again, it's not part of our workshop for today because if I do calculations, I need more time. Horizontal two-phase, and also we have horizontal three-phase separator. These are the most common one. Yeah, and these are very much used nowadays in most of the oil fields. A three-phase separator. I'm asking you, why three-phase? The answer, because we have three flow out of the separator. We have water stream, we have gas stream, and we have oil stream. So three phases. What about sand? Sand may be accumulated within the water part. What about H2S? H2S is inside within the gases goes. What about paraffin? You mentioned paraffin is a problem. Paraffin will be inside the oil. What about scale buildup? The scale will be in the water apartment, because scale based on the type of the salt, calcium or magnesium, and that's in the water. We have mentioned demister in different ways. Could be on the outlet, could be in the middle of the separator. A new word now came to me is weir. Weir, another internal component. So remember, now we have mentioned internal component for the separator. We mentioned the inlet diverter, that's internal component. We mentioned the demister or mist extractor. And now we are mentioning the weir. And the weir is a baffle to control the level of oil and stop any water to jump over it, like a separation, mechanical segregation, I can say. So remember, we mentioned inlet diverter, we mentioned demister, we mentioned weir, and we mentioned vortex breaker. So far, we mentioned these as internal component, and each component has a function, a job to do, to help the operations of separation. You cannot say I am a good separator engineer unless you know the inside of the separator. And you have to have also some problem need to be looked into. Somebody raised hand, his name Redmi. I don't know, that's up to Nikki. Three-phase separator, which is usually a most common separator used in the production operations. If I talk about separation and full stop, not enough. I need from you as a surface production engineer or operator, you should know about your equipment, your facilities. That's important. I repeat myself. The name will be the name, three-phase or two-phase, horizontal or vertical. The principle remains same principle, which is pressure differences and a gravity factor. But the designing is different. You see, this is the designing. There's another one. There's another three-phase separator, but in a different design. I have one inlet and I have three outlets. I have a gas outlet, I have oil outlet, and I have water outlet. But the designing is a different way, different designing. This was something else. This is also typical three-phase separator horizontal one, as I mentioned to you earlier. And we mentioned the weir and so on. So same principle as we have. Externally, now I have mentioned to you internally, I have inlet diverter, weir, vortex breaker, demister are these internal components. The external component, I could see something like a pressure gauge, a thermometer or temperature gauge, I can say. These are this a sample of for a pressure safety valve or pressure relief valve. That's on the top. They send the gas to the flare if needed in case of emergency shutdown. And also I have externally a control valves, a one-way valve, a choke, they call it check valve, one-way valve, to send the gas for processes later on. And if I have problem with the processes, I send the gas to the flare. So I have a pressure controller, as well as I have level indicator for the water, or level controller for the water. And I have also a level control for the oil from this side. And I have something called the sight glass, which I can see the level from in my eyes. Sight glass is just a monitor, does not control. The control is come from the controller of the level of oil and water through the control valves. If you see, if you follow this zigzag line, it's connected to a control valve. This to take the water out, and this to control the oil out. Here we have the vortex breaker. Remember I mentioned that to you? One on the oil side and the other one on the water side. That's to prevent swirl and to prevent gas escaping with water or gas escaping with oil. they call it gas blow-by. We have for the demister as below, we have a demister inside. Also, we have here coalescing plates. And this the job of this is from the word coalescing, mechanical gathering of liquid droplets. So it will help to remove any mist or gathering or liquid droplets from the gas stream. I repeat myself. I used to work as a production engineer for almost 6 years. And at that time, as a young engineer, I don't know very much about the inside of the separator, but I feel now it's a mistake. So my advice for the operators and for the young engineer working in production, I encourage you very much to know the internal components and their functions of the separators. You should know that. That will give you a better understanding if there's any problems later on. It helps you to do troubleshooting if you know the internal components. So you need to know the weir, oil vortex, and water vortex, inlet diverters, the coalescing plates, the demister. And also we have something here, what they call them for the sand removal sometime, to wash the sand or service water connections. If I want to wash the inside of the separator from any dirt and sand production, I connect this part to a water hose. That water could be warm or hot water mixed with some solvent, maybe surfactant or liquid soap, and I wash it, then I drain it out through the drain. This is the drains valve. This one and this one is to drain the separator if we wash it and clean it. So this little sketch diagram in front of you give you the idea of how important I need to know about the internal and external component of my separator. So the important issues which is I could need as production engineer is how much water I have. We call BSW, the basic solid and water or sand and water. How much the sand? Because plenty sand sometimes could lead to a blockage inside the bottom of the separator. Too much sand settled at the bottom of the separator, especially on the water platform or water apartment, it will reduce the holding capacity of the separator. Remember, I have 3 apartments in the separator. I have 1 apartment for water and 1 for oil, and the top is for the gas. And there's some kind of an interface sometime. We call an interface here between oil and gas. Oil, emulsion, and the gas. This one. And this word emulsion also, I don't like it, a problem. So the problems could be an emulsion is a problem. Too much water and too much sand is also a problem because they will block the bottom of the separator and need to be washed from time to time. The GOR, that's the associated gas, I need to make sure that the gas leaving the separator is as dry as possible, free from any liquid or condensate. And this is, we call the process of demister job. And the emulsion, I mentioned is a problem, need to be treated. In the beginning, during production time, during this inlet, there's sometimes you inject demulsifier with the oil. With the crude oil, you inject little amount of demulsifier to go inside the separator to help breaking the emulsion, to help separating water from oil. Sometimes gravity is not enough to separate water from oil, so you do chemical way, and that chemical way is adding the demulsifier to break the surface tension between water and oil and separate the oil from water. So these are important points to consider when we talk about the separators. So you should ask how much water cut, water percentage. In certain countries or in certain companies, they name it as WOR, water oil ratio. Water oil ratio. It also need to be known. GOR, same as gas oil ratio, or we call acetic gas, emulsion, sand. I don't like it. I need to treat it and remove it. And chemical injection. Why do I need to inject? I already mentioned to you I inject demulsifier. I inject antifoam or defoamer. I inject corrosion inhibitor. And sometimes I inject softener to remove or to stop the scale buildup. These could be some of the chemical injections. Of course, they have different trade names. I don't know the trade names. I just say in general demulsifier, and I say antifoam additives or defoamer or corrosion inhibitors or anti-scale or softeners. And therefore, it's crucial to be aware about these chemical additives, and it's part of my operations. Remember, our workshop are production operations. And one of the most important operations is the degassing station, the separation of the separators. And within the separators, you have problems. So you need to know how I deal with it. Within the separator, you need to know what are the internal components inside them, and what is the function of each component. If somebody say to me, Vortex Breaker, I need to know where is it, and what does it do, and how it could go wrong. The Vortex Breaker can go wrong if we have too much scale buildup in the water section, or I have too much wax in the oil section. By the way, if somebody talk about scale problem as a problem, that usually happen in the water section. If we talk about the paraffin blockage, that it happened in the oil section or oil apartment. If we talk about emulsion, then will be between the oil and water interface contacts. In that area, in that line here, in this line, I have an emulsion because the oil is in touch with water. And due to turbulency, we have that issue. I hope that a few messages is clear for you or useful for you. Of course, liquid leaving the oil, I mean, or water, sometime liquid, leaving the separator should be under control, flow rate and quality and so on, and that's important to look into as well. I'm sorry about the noise. I don't know if we should remove that later on. So the horizontal separator, again, they are successful because maybe they have more capacity, better production. They could be different application as well, such as degassing or sludge catcher. Sometimes you call it also separator to catch the sludge. Sludge is a mix between heavy oil with water on some sand particle. If free water knock out, if you have a high water cut, 65% or whatever, and then you have free water. We have two types of waters, by the way. We have free water, which is no oil in it at all, and we have an oily water, which is the emulsion, which need treatment. This one, the treatment in number 6, this number 6, no much treatment needed. This could be used later on as water injection in the future if you want to treat it in a proper way. Maybe on pH value, if you make pH about 7, because most of the free water, most of it has a pH less than 7 because of the H2S solution inside it. So it's acidic. Maybe has some sand particles, so maybe need filtration and needs some kind of dilute caustic soda additives, alkaline additives to control pH value. And number 4, do we have something called, well, yes, sometimes we have called, some people call just only on the wellhead connect, small separators, smaller production, only one well. We could also connect directly, usually spherical in shape. Do we have test separators? Yes, we do test separators. When I do testing for a flow rate coming from a well, to test the formation damage, to test the productivity index, to test the IPR, I may connect the wellhead with small portable separators to see how much gas, how much water in it, how much oil. Production separator, as I mentioned, EU 3-phase, 2-phase, and so on. Degassing drums, that's like a storage tank where the gas come out due to gravity and timing. We have the gas scrubbers. This is very much look like a gas absorber, actually. I mean, you pass the gas through a vessel filled with liquid, could oil, could be diesel, could be kerosene, and that will catch up any hydrocarbon liquids from the gas itself. So these are all under the title of separators. Flare scrubbers as well. If you see at the bottom of flare, there's a little little hump where the liquid comes through it as well. I don't like the noise, so I will take it out. How much allowed? This is the question come, which is I like this question actually. I would like this piece of information. How much is allowed for a gas to take oil with it? Carry over, how much carry over? They give a limit or a standard. They said if 1,000,000 cubic feet, 1,000,000 scarf, the standard cubic feet, it carries only 0.1 gallon of liquid, could be condensate, could be hydrocarbon. That is normal, that's acceptable. So if I go for a separator like this one, and I say gas out, and for every 1,000,000 cubic feet of this gas out, if I have 0.1 gallon, 0.1 gallon is about 300 milliliter or 350 milliliter of liquid, then it is acceptable. That's the meaning of this carryover, which is need to be looked into. Of course, the mist extractor or the demister should capture liquid at a certain size. Sometimes you say 5 microns, sometimes you say 10 microns. No more size, no more larger than this to leave as well. So remember this now. Make a note of it. The acceptable standard, the acceptable operating standard for liquid carryover with gas is about 0.1 gallon for every 1,000,000 cubic feet leaving the separator. And the size of the liquid droplets should be no more than 10 microns. And that little formation could be a standard formation. As I said to you, we have different design for separators. So this is another design. This is another design, clever design. This one is to avoid the emulsion issue. They have a bucket here, just to get the oil clean from water. So if you have an issue with emulsion in your oil field, try to recommend a bucket three-phase separator, an oil bucket. Look like this. That will give you a drier oil, especially if you have a large water cut, too much water coming through. The water cut, the water oil ratio, depending on the pressure depletion in the reservoir, depending on water coning issue in the reservoir, depending on the perforation location in the completion process of the oil, depending on water injection process, especially if we have early breakthrough or we have heterogeneity, or we have fingering. These factors sometimes affecting on the value of water oil ratios in my production. Another designing on purpose, I brought all these slides for you to tell you that same principle, but different design. Again, we have oil, water, gas, demister, and this is the shape of the demister, this one. A plate, a zigzag plate. We call it coalescer sometimes. Coalescer, that means gathering. Coalescing means gathering. Gathering droplets of liquid together, make a large one, and they fall down. This is coalescing. Another designing as well. So I pass through that. And swirl, for example, if I have small particles or demister, so can I do the centrifugal hydrocyclone? The answer is yes, can help. These are on site. Another designing for vertical three-phase. This is vertical three-phase separator. Oil, water, and gas on the top. And you should think about the designing issue, demister as well. Same name, demister, inlet baffle, gas outlet, water outlet, same names, but different design, different design. The vertical separators usually suitable if you have large water cut or you have a small space, you have not much space, especially if you are an offshore platform, or you have too much sand production. So vertical separator is suitable for small space on a platform in offshore. Water cut is high, sand production is high, and it helps also in gravity segregation. Another example of three-phase vertical separator. Another example of three-phase vertical separator. Different designs, very different designs. But you need to know these things as operating engineer, as a process service production engineer. It opens eyes sometimes. I mean, I like it very much because I did a design course when I was in the university, and I love designing things. It gives you an idea. For example, in the designing, they told me, if they told me that I have too much water, so I know this is this area called downcomers, and this is the baffle, look like a weir anyway. On purpose, from the gas apartment, if the liquid drop in, I try to make the liquid goes inside the water, not inside the oil. Then if it's water, it remains in the water. If it's oil, because of gravity factor, will go up and join the oil. And by this, I separate as well oil from water. So these are horizontal separators are very good for larger production rate, larger gas oil ratio, suitable for it as well. They are economical because you can handle too much oil into once, and it has little problems with the production rate. But of course, it has a foam issue and emulsion issue. So this is also a typical three-phase separator with all internal components inside them, which I mentioned already to you. I mentioned you the inlet diverter, the coalescer, the demister, the vortex breaker, the weir, the water outlet, oil outlet, gas outlet. All these are, and also we mentioned the wash out or the water wash to clean the bottom of the separator. These are inlets, and externally components such as the pressure gauge, the thermocouple indicator or thermometer, the pressure safety valves. Sometimes they put also a rupture disc, the inlet of the crude oil, the inlet of washing water, the sight glass, the control valves for water, and the control for the oil. These are external components. And these problems sometimes happen at the bottom of the separator in the wax or asphaltene or sludge, which is a mix of sand particle with oil and water. Need to be washed from time to time. Inlet, also they have different ways of designing it. Remember I mentioned inlet here. I mentioned inlet in many times. Inlet diverter, we call it. So the inlet diverter have different shapes sometimes, like a cup shape, like a shelf shape, like here, a dish, like a baffle, different designing. But at the end of the day, it has one principle. The principle is momentum control. Mass time velocity. Reduce the velocity will help in segregation or in separation. I want from you, from this workshop, to have these issues in front of you, or to have these words I mentioned to you: the inlet diverter, the vortex breaker, the coalescer baffles, the demister or mist extractors. Make a note of them, understand the function of them, and at the same time also, as a workshop, know the importance of designing equipment, oil and gas equipment. The designer play an important part in the operations. Even they said, for example, the problems in the industry is made of three types: either operational problem. Make a note of that. We have three types of problems in the oil industry. One called operational problems, due to I'm not following the procedure. I'm working wrongly. The operation is wrong. We call it operational problems. We have manufacturing problem, the way the equipment be manufactured. Could be poor quality materials, could be very corrosive, could be small capacity, could be a cheap quality. So the way the manufacture is wrong. And third problem is coming from design, called designing problem. So if you have something wrongly designed, you will have also problems later on in operating that equipment. So designing is important as well in the production operations. These are different types as well of separators. Very much common, we call them sometimes the three-phase centrifugal inlet. And these are usually used in gas condensate reservoirs. And that kind of centrifuge movement will help also in separation, like a vortex tubes, the inlet, so that centrifugal movement will separate liquid from gas. Give you better efficiency of separation, in other words. Yes, it has a problem later on, need to cleaning, need maintenance, but as efficiency is very efficient. One of the issues sometimes, if I have a surface of liquid and horizontal separator, like this one, like here, and if the gas is moving this way from left to right, maybe the gas will create a wave, make the surface of the oil as a wavy surface, same as you have a wavy sea or wavy ocean. And that wave, if you have them, then some of the liquid will escape with the gas. You lose your oil, you lose your condensate. So I put some baffle on the top of it, covering that surface to prevent that wave to happen. So that's baffle sometimes helping me to prevent the wave to be created. Foam. I said to you, I think I mentioned that this morning, foam could be breaking down either mechanically or chemically. Chemical, I add anti-foam additives, a chemical that breaks the surface tension. Or mechanically, I can put inside the separator a baffle or a blades. You see these blades, piece of metal or pieces of metals, blades of metal inside the separator. So when the gas passes through, it will break the foam, it will break the bubbles. Sometime in summertime, our children play with the bubbles. They take soap and water and they blow and they make bubbles. That bubbles come because surface tension between air and soap liquid. The foam inside the oil separator make between the gas and the viscous oil. That foam, if I don't remove it, it will reduce the efficiency of separation. And it will encourage some liquid to escape with the gas. I said the allowed amount is 0.1 gallon for every million cubic feet. But if I have foam, that 0.1 could be changed to 0.5 or 0.6. I will lose more condensate. So how do I break it? The answer, chemically, I add chemical called anti-foam additives, or mechanically, inside the separator, I put pieces of metals inside them to break the bubbles and to prevent the foams. So there's a problem, remember now, wave is a problem, foam is a problem, vortex is a problem. Vortex is due to pressure and level. If the pressure is very high and the level of water or oil is very low, the gas will push through it, make the water escape like a swirl, and the gas will go out, gas blow by. And then I lose the gas. I will damage my pump. If I have a water pump, if I have oil pump connected to my separator, like this one, I have oil outlet connected to a pump. If that air or gas come with the oil, so the pump will be confused, the valve will be damaged. I have like vibration and knockdown of my pump because gas and liquid go inside the pump, and the pump is not designed to pump two phase, it is only a single phase. Then I will damage the pump in this case due to vibration. Demister is a problem, mist eliminator. So mist escape, we call liquid carryover. I have to stop that, and we have different type of demister. Could be like this, like a mesh, could be hydrocyclone, could be a zigzag veins, could be a channel veins, coalescer, different designing. Could be like this one, the angle iron, which is like a V shape, veins. So different design. This is also kind of a coalescing pack. These usually we see them in the gas streams to capture the liquid droplets from the gas down to 10 microns, which is very good. Demister again here, we have coalescer or demisters. So remember the word coalescer or demister, they have same principle. Both of them is to remove liquid droplets from the gas stream. Both of them have that principle. Different designing I'm passing through. These are gravities usually for the gas to phase separator. This is design as well. I brought all the designing, possible design with me today just to show you that the production operations, especially on stage number 1, the gassing station, need from me as engineer to understand what are the different types of the separators and why. Why do I use this vertical, why use horizontal or spherical? Here, if I ask you the gas outlet, why the gas outlet has this pipe is going upward? The answer, to make sure the gas leaving is free from any liquid as much as I can. Here, the gas liquid out taken from down up. How it moves from down up is due to pressure differences. Pressure of oil is high and push it up. Same thing with water cut. Different designing is important to give you a successful job. Spherical separators also common in low production rate. We talk about 200 barrels per day. Could be one well, could be 2, 3 wells together. And the principle again depends on gravity and so on. So the inlet, here we have the inlet diverters, different shape, semi-spherical, half a circle, half a sphere. And the demister, the clever part of it, the gas will go up and come down again. This is another type of 3-phase, or actually two-phase spherical separator. You have 2 outlets, the gas outlet and the liquid outlet. Same I think, also you have also pressure gauge on it, you have sight glass, you have pressure safety valves and so on. So another one. This one is, we call sometimes the double barrel. This is common into a high gas oil ratio onto gas condensate reservoirs. So you have the inlet, plenty gas taken out. This is usually condensate taken out of it. The gravity play important part, demister in this case. This one, if you have, you remember I mentioned sand, and I mentioned sand is a problem. So one of the way to remove sand from oil, or especially from gas, is to put inside the separator, you want to put a filter to filter out the sand particles. So you put here clearly sand or gas out will be free from any sand particle. The condensate will gather here. So in this case, I have actually gas, condensate, and the solid particle will be filtered out inside the filter. That tell you, separators have different internal components based on what? Based on the properties of my crude oil. Do I have heavy, light crude oil? Do I have it a clean crude oil? And many other things need to be looked into. Yeah, I will stop in 5 minutes, hopefully, because I will cover the timing. Because somebody sent me a message for to stop. We have, as a separator, sometimes different stages and these are different information and things need to be looked into. I mentioned all these factors already. I mentioned instrumentation and control, level, pressure, temperature. I mentioned them already. The alarms, usually, if the level is important to have an alarm level for it, or for water and oil. Pressure also, you have to have an alarm for it. Temperature as well. These are the alarming things which you need some time need to be looked into. These are problem I mentioned. Foam is a problem. Paraffin is a problem I mentioned. And paraffin could be a block. Remember I mentioned the blockage of the demister due to paraffin, waxy things. Sand I mentioned as a problem. Liquid carryover and gas blow by, I both of them mentioned them. Sludge, I mentioned this word. So we can discuss many issues later on because it's a workshop. And a workshop, I wrote for you so many questions here, which we can discuss them with you. Uh, uh, I will leave these slides with my friend Nikhil or Nikhil, and I'm sorry if I announced the name